OK, we are talking about the state of Prometheus and OpenTelemetry interoperability. First of all, show of hands. Who is using Prometheus or OpenTelemetry? Who is using Prometheus and OpenTelemetry? And who is liking the experience? OK. I'm sorry. I'm Arthur. I work for Grafana Labs. I'm a maintainer of Prometheus for a few years now. I joined OpenTelemetry recently. I've been contributing for like 6-7 months. I got approver status in the collector. Besides that, I also do mentorships through CNCF mentorship programs, Google Summer of Code, LFX. And Grafana pays me to make sure that Prometheus and OpenTelemetry work well. Apparently, I'm not doing a good job. But I hope we improve over time.
Hi, so I'm Juraj. I'm an SRE with a focus on observability in Swiss Re. And I'm also OTel and the Looks Good to Me stack contributor. I'm also an active member of the OpenTelemetry and Prometheus special interest group. And last year, I also became a Grafana champion.
Cool.
With Prometheus and OpenTelemetry, they sort of got off at the wrong foot. And at least partially, that's due to philosophical differences around how to collect metrics, right? Whereas Prometheus is predominantly a pull-based model, OpenTelemetry, at least in its current implementation, is predominantly a push-based model. So what's the differences? What are the pros and cons? With the pull-based Prometheus model, Prometheus relies on service discovery to know what's supposed to be monitored, and it also allows us to have metrics such as the app metric in Prometheus, which we can use to monitor for failed scrapes. However, there are some disadvantages to this approach. Apps need to keep the metrics in memory, and if your metrics don't change frequently, if they keep the same value for a period of time, we are wasting CPU and network to collect the same data over and over. Whereas with the push-based model, we don't need to keep the metrics in memory, and we can only push when there's actual data to push. However, we don't have the service discovery, so the Prometheus can't tell what's being monitored. And even if it knew what's being monitored, it can't tell easily the difference between an application that went away versus an application that's just unavailable due to, for example, a network issue. We won't go into the nitty-gritty details of things, but Prometheus is also very much designed for pull and regular intervals. And the implementation of very popular PromKill functions depends on these characteristics. Without lowering the lookback delta in Prometheus, you can also keep getting the basically last data point for your application that went away for up to 5 minutes.
So this philosophy difference brings me to this people management theory called the tree of monkeys, where the same group of monkeys, they work towards the same goal. There's a banana in the top of the tree. And they need to work together to get there. But in reality, the monkey that sees, if a monkey sees the other one progressing really, really fast, instead of collaborating, it starts to see the other as a threat to their own success. And I'm not proud to say, I've been a Prometheus user for almost a decade now. And at the beginning, I did see OpenTelemetry as a competition instead of a collaborator. But if we compare the two, like, why do we see them as competitors? Like, Prometheus is a time series database focused on metrics, and it has a lot of features that allows monitoring and alerting systems, while the OpenTelemetry is not a backend. It's not a database. It focuses on creating telemetry and making sure that telemetry types correlate well together. So if Prometheus doesn't exist, OpenTelemetry still needs a good backend for the metrics. We could say that we compete on the SDK side. Like Prometheus has SDKs to instrument metrics in your applications. OpenTelemetry has the same. But Prometheus focus on the very efficient Prometheus way of doing things. OpenTelemetry has a different goal. OpenTelemetry focuses on context propagation between the telemetry type and to make sure that it works for every vendor out there, not only Prometheus. So now that we realize that Prometheus can focus on being a collaborator with OpenTelemetry, and will work to make the best OpenTelemetry metrics backend. Actually, that's what happened in PromCon 2023. The team meet in person in Berlin. We had a full-day meeting, and we decided that, yes, we do want to be the best backend for OpenTelemetry. And to do that, we realized that we needed to introduce some breaking changes, and that's how Prometheus 3.0, there are not only OpenTelemetry, but OpenTelemetry was a big factor to release the 3.0. When we get to the work, it's a lot. We have too little time to talk about all the new things that we developed in the last year. So we will hush through it, and if we have questions at the end, please ask as many as you want. Starting with UTF-8, historically, Prometheus only accepts digits, the English character set, underscores, and columns, while OpenTelemetry accepts the whole UTF-8 character set. That includes foreign characters, dots, symbols, emojis, everything that comes up to your mind, OpenTelemetry accepts. And in fact, if you use OpenTelemetry, you know about the semantic conventions, and there is dots everywhere. There is no way we can adopt OpenTelemetry metrics if we don't accept the dot. With 3.0, Prometheus starts to accept UTF-8 by default. We are also making the OpenTelemetry receiver endpoint stable. We don't need a feature flag anymore. We do need a flag because of security reasons. We cannot expose an endpoint that can write to a database by default. That's a security problem, so we need a flag. And we also have, in the configuration file, strategies to translate OpenTelemetry metric names to Prometheus metric names. That's, yeah, this is something that we definitely want to improve. I wouldn't say this is the final OpenTelemetry to Prometheus experience, but that's as far as we got. If you were in this room yesterday, Bartek and Ariana gave a talk about Prometheus adopting OpenTelemetry schemas. This is still work in progress. It's not released, but this helps. You can specify there's a metric that was following the Prometheus naming conventions on version, let's say, 1. And the same metric, there is a new version called, let's say, 2.0 that follows the OpenTelemetry semantic conventions. Prometheus will be able to query both, and they will show up in your graphs as one single metric. This will definitely help with migration, but still not released. If you're using Prometheus-like backends, but not Prometheus, just be sure that they do accept UTF-8. I'm not sure if all vendors, all implementations accept, so just keep an eye on. We still have work to be done on UTF-8 side. I have no idea how to predate the OpenTelemetry spec, but that's on my to-do list. I want to propose change to spec to make sure that OpenTelemetry, when OpenTelemetry is sending data to Prometheus, it's fine to keep the UTF-8 characters. Today in the spec, it requires a translation, and I don't want to stay that way. The OpenTelemetry collector has two Prometheus exporters, the Prometheus exporter and the Prometheus remote write exporter. They are translating UTF-8 characters to underscores. I don't like that. People don't like that. We are working on it. Oh, sorry. Changing topics. Deltas. Deltas, if you work on Prometheus, you realize that counters only go up. When a counter goes down in Prometheus world, we say that this is a reset. And the rate and increase functions, they are implemented in a way that we are able to work around those resets, and the query results still work. But in OpenTelemetry, there is more counter types, the deltas. So there's a quick illustration. If, let's say we have an app, we are measuring HTTP requests. If we receive in 10 seconds 12 HTTP requests, the cumulative value will go up to 12, and the delta one will also go up to 12. 10 seconds pass, we have only 2 requests. The cumulative will keep the state from the previous measurement. It will increase by 2. The deltas, they measure the increase between one measurement to the other. So it will only count +2 instead of 14. And then that happens for every single measurement. So we can translate things. We can translate cumulatives into deltas and deltas into cumulative. But to do that, we need to hold the state. We need to keep in memory the previous measurement. And with the state, we can calculate the translation between the two. If you're sending metrics to Prometheus, so far, we only accept cumulative. So we built in the OpenTelemetry collector a processor called delta to cumulative. It will hold the states of the previous measurements. We'll do the translation just like I just said. As every stateful process, it's hard to manage. So the author of the delta to cumulative processor open a PR in Prometheus so we can embed this processor in Prometheus. So instead of running 2 stateful processes, you run only Prometheus, and it will run the delta to cumulative processor in Prometheus, so Prometheus does the conversion alone. This is not the best experience ever. I don't think this is going to be scalable. We are working on a better support. We want to do the conversion. Actually, I'm not even sure if we want to do the conversion. We want to ingest deltas as they are. And if we want to transform into cumulatives during the query time, or if we want to have different PromQL functions to handle deltas, this is still under discussion. But keep an eye. We have PRs open. We have proposals. We are definitely improving the experience around deltas.
On another topic, native histograms. As you might have heard, native histograms became a stable feature in Prometheus 3.0, and they improved the performance and accuracy. They're also atomic, so a whole histogram can be contained in a single request, which allowed us to create the Prometheus remote write receiver in the OpenTelemetry collector. There's still some work to be done, though, so they're not officially marked as stable yet. One of the things missing is the implementation of native histograms in the OpenMetrics text format, and there might be still some bug fixes needed for the query side of things, but you can use them in production already. And as you can see on the screenshot, 7.3.3 issues have been already resolved, and basically there's one last pending, so it's very close to becoming like an officially stable feature. Another new feature in the Prometheus 3.0 is Prometheus Remote Write Protocol version 2. It enables new features while definitely also maintaining the efficiency aspect.
Oh, sorry.
Yeah, it does have support for the native and classic histograms, which, as we mentioned, are more efficient and accurate.
Do you want to hold this?
Yeah.
Probably
Let's do that. It also has support for exemplars, which allows linking metrics, for example, to traces. Previously, there was only an experimental support for it in the remote write protocol. It also has a native support for metadata, which now is no longer just scoped to the metric name, but it's scoped to the actual series. And the metadata is basically the description of the metric, the type, and the unit, and they're also no longer optional. Creative timestamp support, which improves the accuracy of rates, and for Shovely time series. And as mentioned, we also have in the Prometheus remote write protocol, we also have full UTF-8 support, added specifically to improve compatibility with OTel, because in the Prometheus remote write version, you would have to do the translations. What does this mean for OpenTelemetry? As I mentioned, this enabled us to implement the Prometheus remote write receiver in the OTel collector and allowed us to make the component stateless. There is an ongoing work to make it better. You can check out the details in the tracking issue. It also brings improved support for alt and exponential histograms, which get translated to the native histogram. One of the reasons being now they can be shipped in a single remote write request instead of being split into multiple time series, the individual counters in the old histogram, which can come in multiple different requests. Avoiding conflicts in the metadata. So previously, because the metadata was scoped to per metric name, if you had two different applications with the same metric name, for example, like the HTTP metric in OTel, which has an ongoing migration to change the unit type, you would have a conflict in the unit, basically, if not all your migration applications were already migrated. This solves it. It also, the UTF-8 support enables us to store the OTel metrics without having to escape dots, which are commonly used, as mentioned before. And the Prometheus remote write v2 also brings partial write statistics, which give an OTel collector a bit of idea if a request was partially written, how much data was written, how much data was rejected, and if it's worth retrying. And there's also ongoing work to implement the support for the Prometheus remote write v2 protocol in the remote write exporter. You can check the tracking issue for more details.
Resource attributes, that's a spicy one. So one thing that I really like on the OTel SDKs is the ability to find attributes about the resource, about the application that is running. So for example, if it's a Java application running with the Java SDK, we'll find information, for example, the Java version or the CMD line that run the application. If this app is running inside a Linux host, it will find information about the host itself. For example, the host, the OS name, things like process PID, the architecture of the CPU. If it's running inside a container, it finds things like container name, container ID. If it's running inside Kubernetes, you can use Kubernetes receivers to add more metadata to the application. But when we are sending this information to Prometheus, you just put that inside of a huge bag of information. We throw it to the other side, and we hope for the best. Hope is not a strategy. Things do not work as we want. And while trying to support resource attributes, we are iterating several times. And I think we are still not in the place we want to be. The first strategy that we had was to transform all the resource attributes into Prometheus labels. If you run Prometheus, as I could see everybody here is using Prometheus, if we have labels, for example, pod ID, container ID, process ID, like this is not a good label. You will never run a query that, let me sum memory usage by Java CMD line. You just don't do that. And we are storing that as a label. We are wasting CPU. We are wasting memory. We are wasting resources. And we are always hitting cardinality issues. We changed the strategy. This is what we have in the spec, the OTel spec at the moment. All resource attributes are being translated into a single metric. And the single metric is called target info. And you can use PromQL joins to join the target info labels, and you put that in your metric that matters, the metric that you're actually querying for. But joins, I don't like joins. I've been a Prometheus user for 9 years. I'm a maintainer for, I think, 2 or 3 years. And I still Google how to do joins. And I think you do the same. Like, this is a hard, that's a barrier. That's a barrier for users to require to use joins to use in your metrics. Yeah. Third strategy. We are telling the user you are intelligent enough to tell us what are the resource attributes that matter for you. So in the configuration file, there is an option called promote resource attributes. You tell us what to promote into labels, and those resource attributes will be there in your metrics. This is so far, the best user experience for a Prometheus user, terrible experience for the Prometheus sysadmin. Because if you change the resource attributes, if let's say I'm a platform engineer and I provide Prometheus as a service to my developer teams, and my developer says, I don't like this resource attributes anymore, I want a new one. So you change the configuration file, you need to restart Prometheus, and we change the time series ID, let's say. When you change a label, you create a new time series. And Prometheus, to be like a real-time monitoring system, we keep the most recent metrics in memory. So when you switch the resource attributes, you have a set of metrics in memory, and then all the labels change. So you still have the old metrics in memory, you have new metrics in memory, so you double the amount of memory for a while, and usually that breaks your installation. We are doing some UX research. We are mentoring a young woman from Nigeria. She's interviewing a lot of Prometheus end users, OTel users, co-founders. We are asking a lot of people information about like when the OTel metric data model was created, what was the co-founders thinking of a good database for the resource metrics? Like as a OTel SDK user, what do I expect from a metrics database to handle the resource attributes? Well, this is still work going on. I hope in May we have some good new ideas, and after May we start implementing them. One thing that I'm really excited about resource attributes is the OTAP, OpenTelemetry enhancement proposal that talks about entities. If we go back a few slides, I was talking how we have really nice resource scoped, like there's the Java resources, that are the host resources, container resources. They are very well scoped together, but when we send them to Prometheus, we just put them on a bag, and we lose all the scope. With the entities, we will be able to identify from those resource attributes, which ones are supposed to be Kubernetes attributes, which ones are supposed to be container attributes, and we'll be able to have a better experience in Prometheus based on this information. So just to recap, things that to look for in the future, we have ongoing work to adopt OpenTelemetry without any metric name modifications. So far, we are able to accept UTF-8 characters without translating to underscores, but we are still adding the suffix for units and types. For example, the underscore total, things that in the Prometheus world makes sense. That's how we always done things, but in OpenTelemetry, that's new, and the feedback we receive is that people don't like that. We're working on native Delta ingestion. We are working on remote write receiver and exporter in the collector. We are working on the remote write protocol was always designed for Prometheus, and Prometheus never accepted Delta in the past. Since we are starting to work with Deltas, we might make changes to the remote write protocol to also have a good experience with Deltas. We want to make changes to the OTel spec, mostly around native histograms and UTF-8. I promised not to say this, but fuck it. We also have a working group around Parquet. It's really early, but with Parquet files, we should be able to handle better high cardinality attributes. And I think for OTel, it makes a lot of sense, since resource attributes are usually in the set of hundreds, 200 resource attributes, and Parquet might be a very good use case to handle resource attributes. This is a QR code if you want to give us feedback, and thank you for being here.
Thank you. Any questions?
Thank you for the talk. I have a question. For the resource attribute, instead of promoting the resource, is there an option to have a regex so we can put a star like, I don't know, resource dot star or something around those lines? This is the first question. Or can we put, instead of promoting, blocking? So skip those resource attributes like command line. You don't want.
Like
you don't want to filter based on that, but maybe you want to filter based on the rest.
Like a deny list.
Right, right.
Yeah, those are good ideas. I don't think anybody suggested that. I think that's fair ask. Let's open an issue and implement it.
Also, if you use the OpenTelemetry collector to ship some of this data, you can always use the OTel collector processors to do the transformation on data you want to do before it comes to the remote write exporter, which might allow you to do some of these changes already.
Right, this is a good idea too. Yeah. Thank you, guys.
You're welcome. Okay. Sounds like we're done.
Anyway, if you have... Oh,
thanks for the presentation. A quick question coming back to the join topic and the info labels. I think you have added a new info function to the Prometheus language basically for this
yeah.
case. And do you think it solves it for this OpenTelemetry use case, or is there something specific there that...
I think the info label is definitely better than joins, but I don't think it's the final solution. But yes, it's a very good, definitely better than the joins. Thanks for calling that out. All right, let's have lunch.